Alright, this is concept 59, complex fractions. A complex fraction is a fraction in which the numerator and denominator both contain fractions. To simplify a complex fraction means to rewrite as a single fraction with no fractions in the numerator or denominator. So, steps to simplify. The first thing we're going to do is create a single fraction in the numerator and denominator. 2. Set up as a division problem, then multiply by the reciprocal. 3. Simplify, factor first if possible. So the way to think about these expressions is, so here's number 1, okay, if you're given this fraction here, a over 2 divided by, or over a squared over 4, okay, the fraction here can be seen also as division, right? So you can think of this expression as it's really saying this. And then when you have this, you would switch the operation to multiplication and you take the reciprocal. So that's what we're doing here. Okay, that's what step 2 is basically saying here. So for the first one, you can rewrite this as a over 2 times 4 over a squared. Right? Switch to multiplication, take the reciprocal of the second one. So, and it's multiplication, so you can multiply left to right. So 4a over 2a squared, and then here you're going to simplify. 4 over 2 becomes just 2 in the numerator, and then a over a squared, the a's would cancel there, and I'm going to get 2 over a, like that. And that's it. That's all I can do. For number 2, same thing. So just to save space here, I have 6 over x y times 8x to the third over 3y. So I switched to multiplication and I took the reciprocal. This multiplication, you can multiply left to right, so I'm getting 48 x to the third over 3x y squared. Now 3 goes into 48 16 times, yes, so that becomes 16, and the x here will cancel one of these out, so I get x squared in the numerator, and then the y squared, I can't do anything with it. So my final answer would be 16x squared over y squared. The third one, they start to get a little bit more complicated, okay, and what you want to do is, just like the third step says, factor first if possible and simplify anything you might see that makes this just an easier expression to work with. Okay, show as many steps as you need so that you don't make any mistakes. So I'm going to rewrite this as a product and reciprocal. Now I'm also gonna, let's see, I'm gonna simplify the denominator of the first term. Okay, so I have 18p, that's the numerator here, that's the numerator. Okay, now ap minus 2, I'm gonna factor out a 2 first. So 2, I get 4p minus 1 times, and then it would be the reciprocal of this here, right? And I can't factor out anything there, so it just stays as 4p minus 1, and same thing goes for the denominator, 4p squared. Now notice that these here are going to cancel, and then 18 over 2, you can say this goes away and this here becomes 9, and I have one p here that will cancel out one of the p's down here, so I get left with just 1. And then 9 over 4, I can't simplify either of those, so I get left with 9 over 4p. Number 4, same thing. Looking at this first one, there's nothing I can simplify there, so k minus 1 over k times k squared, that's the reciprocal right now, it's on top, but k squared minus 1, I notice that that's a difference of squares, so this one does factor. I can write this as k plus 1, k minus 1. I see these cancel out here, and then this k will cancel out one of the ones there, so I get just 1k, and then that will be it. So I get k over k plus 1. Alright, number 5. I have 7c plus 35 over c. I can factor out a 7, so I get 7c plus 5 over c. Whoops, that's equal. Sorry, I forgot my equal sign there. Times c squared over c plus 5. This cancels with this. This c here will cancel out with 1 there. So I get left with just 7c. That's it. Number 6. Okay, they're starting to get longer, but just, you know, have patience. Take a step at a time. B plus 2 in the numerator. B squared plus 6b plus 8. I can factor this out as b plus 4, b plus 2. Yeah. So then times, take the reciprocal here, right? And then b squared minus b minus 20. You can factor this out as b minus 5, b plus 4. Yeah, that's right. And over 1. Now we cancel out b plus 4 there and there, b plus 2 here and here, and that leaves me with just b minus 5 over 1, or just b minus 5. Okay. So I had some students in class tell me that I should make the videos more fun, and I honestly don't know how. So a suggestion was to put in some movie trivia in. So here's your first question. In the first Iron Man film, who was the villain? What was the name of that villain? Okay, I'll let you guys know by the end of question 8. So see if you can answer it. Anyway, so number 7. I have 15 minus 15r over 15r squared. I have a parentheses there just to denote that, right, just the complexity of this one, that it's all one thing there. So first thing I should factor is, I can see in the numerator there 15. So if I factor out 15, I get 1 minus r over 15r squared. There's nothing else I can do there. Times, this is really over 1 in the denominator there. So I get 1 over, and I can factor out a 12. 12 times r, yeah, r minus 1. Okay, the 15s here will cancel. R squared in the denominator, I guess we leave that, but 1 minus r, r minus 1, recall that these here are going to cancel and become negative 1. Okay, and that's it. Looks like that's all I have. So I'm going to get left with negative 1 over r squared. Oh, 12. Forgot about the 12, right? This 12 never went away, so the 12 is included. That's it. Number 8. So geez, as I said, they're just getting longer and longer. Factor out 2 in the numerator, so I get 2m squared minus m minus 20 over, I can factor out a 3, so m plus 4 times, and then take the reciprocal, so the top would be 9m squared plus 36, but I can factor out a 9, so 9m, sorry, so I can factor out a 9m. Okay, let me say it one more time, 9m, so I get m here plus 4. Yeah, then that's over m to the third minus 5m squared. I can factor out an m squared, and I get m minus 5. Yeah, and then I guess because I didn't write it out, I gotta redo this. M squared minus m minus 20, I can rewrite this as m minus 5 m plus 4 all over 3 times m plus 4 times 9m m plus 4 over m squared times m minus 5. Okay, now I can factor out, cancel out. So that one, n minus 5 to n minus 5, n plus 4 here to n plus 4 there. This 3 to this 9, so this 9 becomes 3, right? It's 9 over 3, just becomes 3. And I'm not seeing anything else, so I think that's going to be it. So that's equal to, here, that's equal to, let's see, 2 times 3, 6, m plus 4, over m squared. Oh, no. We forgot to cancel one more thing, right? This m here with this, there's an m squared in the denominator, right? So that m will cancel out 1 here, so I get left with just 1 in the denominator. So over m. Yeah, that's it. Okay, that was a tricky one. So just pause and just look at everything that canceled out, and then you'll see that you'll verify that it's this solution here. Okay. Continue going. 8 more questions. Oh, and I forgot. The answer to the trivia, the villain for Iron Man 1 is the Ironmonger. Okay, so Google it if you don't believe me. Obadiah Stane was the persona. Ironmonger was the when he gets in the huge suit at the end. Okay, number 9. So let's see here. Same idea, but oh no. This one's different, right? I have x minus 3 over x in the numerator. So this is like the previous concept where now I have to make sure I can rewrite the numerator first as 1. That's the panadero, if you were able to hear that. Anyway, so I have to combine these fractions in the numerator first, and I would multiply top and bottom by 3 here, and then this one here by x and x. So I can combine those, this here. Jeez. Okay, hopefully that's the last time. So, nope. Yeah, you guys will get a kick out of this one. So, alright, so maybe first I'm going to rewrite this fraction so it's easier to see what I got before I try and start simplifying it. So, I get, let's see, the denominator becomes 3x. I'm subtracting, right? And then both denominators become 3x. So 3x is in the denominator. The top is x squared. And then here I get 9, so x squared minus 9. X squared minus 9. Over, and then the denominator is nothing I can do there, so x minus 3 over x. So now I can go ahead about this one like I did with the others. I can rewrite the first one here. The top is the difference of squares, so x minus 3, x plus 3 over 3x times, take the reciprocal, x over x minus 3. X minus 3 here cancels out with this one. The x here will cancel out with that one. And then all of this is just x plus 3 over 3. When I was younger, I used to buy donuts from the bread van that's out that you guys heard, but a number of years ago he stopped carrying donuts, so then that was that. Anyway, so number 10, I have 1 over PQ, and then now the denominator has 2 separate fractions here, so I have to merge these and take the same idea, right, as a previous concept. This one's over P, this one's over Q, so I have to multiply each one by the other denominator, right? So that I can get the same denominator. So I multiply the left one by q, the right one by p. This is going to give me 1 over p q over, let me see, the top here will be 4. I write the top, right? This becomes q times p, q times p, q times p, so it's just pq. So it's just pq there. For the numerator of the bottom one, you got q times 1 is q minus p, because 1 times p is just p. So you get q minus p. Okay, pause it if you need to just take a moment and look at this slower. Okay, now from here, I get 1 over pq times, take the reciprocal, p times q over q minus p, and then these guys cancel, and they're equal to 1 over q minus p. That's it. 15. So let's see. The top is they're just whole numbers, right? It's 5 over 4. So I can just, I'm gonna leave those, but the denominator here, this is a very ugly expression here. So first thing I should do is rewrite this denominator, just see how else I can write it. So I can factor out of 4, I get n minus 4. Notice that the other one is just n minus 4. So this one here I have to multiply top and bottom by 4. So let's rewrite that. Well, to save space, I think I'm just going to go ahead and write the reciprocal in this one. So I get 5 over 4 times what would be the reciprocal here. So when I multiply this here, I would get 80, right? The numerator, I would get 80, so the 80 would go to the bottom. But for the top, I have 4n minus 16 minus 4n minus 16. No. Okay, let's rewrite this because even I'm confusing myself here. 80 over 4n minus 16, right? That's this first one here, minus 5 over 4n minus 16. Okay, so it becomes, or the numerator becomes 75, right? 80 minus 5, so it becomes 75. So when I take the reciprocal, I get 75, and then now I can take the factored version of what would be the denominator here, right? You take out the 4, so 4n minus 4. Okay. Now we can simplify, and the 4's cancel there. 5 over 75, the 5 would cancel. How many times does 5 go into 75? 15. So this becomes 15, and I think that's it. You get n minus 4 over 15. Okay. Number 12. The numerator, I can't simplify anything. W over W plus 2. Here though, I have 1 minus W over W plus 2. So I need to make this guy, I need to change his denominator, right? Because he's really over 1, right? He's really over 1. I gotta multiply top and bottom then by W plus 2, because then I will be able to combine them. So I get W over W plus 2 over, now that they would have the same denominator, I can combine them. I'll have W plus 2 minus W. So W plus 2 minus W, the W's would go away, right? W minus W, so you get 2 over W plus 2. Now this one, I take the reciprocal, W plus 2 times W plus 2 over 2. Those cancel, and I get W over 2. 13. We're almost there. Let's see. Alright. I gotta combine the numerator fractions. Multiply top and bottom here by a squared. The left side here by b squared. That will allow me to have the same denominator, so I can combine them. So I would get b squared in the numerator minus a squared. So b squared minus a squared all over a squared times b squared over, now I gotta multiply here to combine these, and I will multiply each one by, or on the right by b, and the one on the left by a. So I get a plus b over ab. Now I can take the reciprocal, so b squared minus a squared over a squared b squared times ab over a plus b. Now let's see. So I see it. So then the numerator here, it's a difference of squares, so I can rewrite this as let's write another line here just to make sure I have enough space. So this is b minus a times b plus a. Maybe that was a bad idea. Yeah. Okay. That's actually multiply left to right and combine it into one. So AB, right? Because I'm multiplying, so it's just b minus a, b plus a. That's this times AB, all over, and then let's keep these separate. That way it'll fit a squared, b squared times a plus b. From here, I can cancel out. Notice that I can cancel out these here, a plus b, b plus a. They're essentially the same thing. They're both positive and they're both being summed, right? So they are the same. So I can cancel these two guys out, and then you can, let's write this note off here to the side. A squared b squared can also be written as ab squared, right? Recall your rules of exponents. This would distribute to each of these, and that's equal to this expression. You have ab up here, so this ab would cancel out the exponents there. Okay, these two here with this one, so you got left with just b minus a over ab. 14. Wow, they're getting very tedious. So to combine the numerator here, this is really over 1. I would multiply top and bottom by n, and then here same thing. That's really over 1. It's really over 1, and I would multiply top and bottom by n. So the top one becomes, you have m minus 1 times n, which is just n, so you get m minus n over n, because now they have the same denominator, over 1 times n here is just n, so m plus n over n. Yeah, that's it. So then we can rewrite this now, right? So I have m minus n over n times n over m plus n, and then n, the n's are gonna cancel, and that's it. Yeah, there's nothing else I can do from here. So I get m minus n over m plus n. This is not that other property, right? Because I have a minus and a plus. Okay, so it's not minus 1. Okay, continuing, last two here. So 15, the top fractions I have here, I'm going to multiply the left one by v. That will give me 4v in the denominator, and then I can combine them. For the numerator, I'm going to get v plus 1. So I get v plus 1 over 4v all over, and then this one is going to be one of those where I have to multiply by each denominator. So the left I have to multiply by 4, to the right I have to multiply by v, and then that gives me the same denominator. So I get, for the numerator, 4, right, because 4 times 1 is 4, plus 1 times v, that's just v, so I get 4 plus v all over 4v. So v plus 1 over 4v times 4v over 4 plus v. The 4's there would cancel, and I think, yeah, that's it. There's nothing I can do. So v plus 1 over 4 plus v. Oh, sorry, I didn't realize I was out of frame there. Pause it and check it out, and then let's continue. 16. Wow, look at this one. So for the numerator, for the sake of space, notice that here on the right one, 5a plus 15, if I factored out a 5, I would get a plus 3. That's what I have here. So I just need to multiply this one, top and bottom, by 5, and then that would give me the same expression I have on the right side. So multiply by 5 there, and I'm going to get, let's see, 5a squared in the numerator plus a squared. Those are like terms, 5a squared plus a squared. So I'm going to get 6a squared over, and then I have the same denominator, right? And I think I'm going to keep it the way I would have it here in the left side, because I'm assuming it's going to let me or make things cancel later. So 5 times a plus 3, right? If I factor out a 5 here, is the same thing. So 5 times a plus 3 over, now here I have to multiply the right one by a plus 3, and I have to multiply the left one by 5. That'll give me the same like denominator. So multiply here by a plus 3, a plus 3, and then here by 5. And then that's the same thing, right? 5 times a plus 3, a plus 3. So the denominator should be the easy one to write, 5 a plus 3, like that. And then for the numerator, 5 times a is 5a plus 1 times a plus 3. So I just got left with a plus 3. But 5a plus a, those are like terms. So I got 6a plus 3. So from here, now I can rewrite that as 6a squared over 5 times a plus 3 times 5 times a plus 3 over 6a plus 3. Those all cancel there, and I get left with, let me see, 6a squared over 6a plus 3. Yeah, I'll be able to cancel further, right? Because I can factor out a 3 here. So let's do that. So I get 6a squared, that's this guy up here. And then for this, I'm going to factor out a 3. So a 3. So 3, and I get 2a plus 1. And then there's 3, and the 6 will cancel, 6 over 3, so I get with 2 in the numerator. And then I get, I just get 2a plus 1. Okay, that's it. So this was a tough one, but hopefully, you know, it's the same skill that's been getting reinforced since last concept, maybe even the first one. So let me know if you guys have questions, and that wraps up concept 59.